Hello everyone, I hope you are doing good. Welcome back to my channel MBB Mohit Sharma. Today's video is about how to sample the data collection plan and various sampling techniques. In my previous video, I talked about how to identify potential axes for your project Y. In this video, I will tell you how to collect data on those axes, how to identify the samples and what sample size you should take. So let's get started with the video. So in this video, let us understand what is data collection plan, how to calculate the sample size, and which sampling technique should be used. Let us understand how to calculate the sample size. The formula to calculate sample size is n is equal to 1.96 into standard deviation divided by margin of error whole square of the entire thing. Level of confidence required for the result. How confident I am that the result represents the true population. 1.96, which is a constant, represents 95% confidence level. Level of confidence increases as sample size increases, or in other words, to increase the level of confidence, increase the sample size, which means that I am 95% confident that the sample will represent the population. Margin of error, which is delta. Margin of error delta required in the result, the error or uncertainty in my result. Margin of error decreases as sample size increases. So, what does this mean? This is a permissible error which is given by the customer. For example, customer has asked you to process transactions and they are okay with 99% accuracy, which means 1% error is allowed, which is margin of error. Suppose in a manufacturing setup you are required to produce rods with 4 cm diameter and there is a margin of error allowed by the customer which is plus minus 0.1 centimeter. So it means you can produce rods with diameter between 3.99 to 4.01 centimeters. Standard deviation of the population. How much variation is in the total data population? An estimate of standard deviation is needed to start. How can you do that? You need to pick up a sample of 30 data points from the population and calculate a standard deviation and put the standard deviation in the formula to calculate the sample size. As standard deviation increases, a large sample size is needed to obtain reliable result. While collecting data, sometimes black belts are confused that my population is in millions. How should I calculate? How much sample size should I calculate? So your population has nothing to do with the sample size. You need to be very careful of. If you look at the sample size formula, the population size is not mentioned anywhere. In this equation, 1.96 represents a 95% confidence level. Let us take few examples to understand this better. So in this formula, the confidence level is 1.96. Your margin of error delta is 2. Standard deviation is 4. If we put all these three things in the formula, the sample size comes out to be 15.3, which is like a round figure of 16 can be taken. Now let us see, the confidence level is 1.96. Margin of error is reduced, which is 0.5. Standard deviation is 4, same. The sample size is 246. Now if you look at this, if we want to reduce the margin of error, we have to increase the sample size. That is being proven by this equation. Now let us understand what happens if we change the standard deviation. Confidence level is 1.96. Margin of error as it was in the first example remains same, which is 2. Let us double the standard deviation and see what happens to sample size. So sample size has also gone double. The sample size has gone up from 16 to 32. If we want to reduce the margin of error, the sample size should be high, and if we have higher standard deviations, the sample size would be high. Next we will learn about sampling techniques. So we have identified the sample size. Now how to pick up that sample size from the population is what we will learn now. The first sampling technique is simple random. Each object has equal probability to be picked, and we hope that the sample picked represents the characteristics of the population. It is easily implemented for services and manufacturing populations. The second one is convenience sampling, which is as per convenience. Take next 20 production objects of a population line or next 15 transactions processed. This sampling could be biased. However, for quick and less expensive data collection, they can be used. Systematic sampling. Sampling which follows a system. Starting point is random and then samples are picked systematically. For example, every 15th transaction should be picked. There is a drawback in choosing systematic sampling. That is, when there are patterns in the population, then you can choose certain type of transactions more or less. For example, there are simple, medium and high complexity transactions in a population of 1000 transactions, and you need to pick every 15th transaction. In population, every 15th transaction is simple or medium complex. Then the entire sample collected will have simple or medium complexity transactions. This sample will not represent the characteristics of the population, as no high complexity transaction is part of the sample. Stratified sampling. Different groups of similar characteristics are made based on location, occupation, complexity or age. Then a random sample is taken from each group proportional to the size of each group. It leads to very good random representative sample. For example, if the sample of 60 is to be picked from 1000 simple, medium and high complexity transactions, then 3 different clusters are made. First cluster representing simple complexity transactions, which is 500. Second cluster representing medium complexity transactions, 250. And third cluster representing high complexity transactions, 250. Then random 30 transactions should be picked from simple complexity transactions cluster and 15 each from other 2 clusters. So I always prefer stratified sampling, as it is a combination of systematic as well as simple random sampling. So we have already learned what is the sample that needs to be collected and what is the technique to collect those samples. Now let us understand how to create a data collection plan. So this is the template which can be used, which has measure name, measure type which is X or a Y, data type which is continuous or discrete, the operational definition, number of samples, and who will collect the data, means data collected by. Six Sigma works on this equation, which is Y is equal to Fx. It means Y is your project metric and X's are different causes on which you need to collect data along with Y. So the first measure name is cycle time that we need to collect for transaction. Measure type is Y. Data type is continuous because it is time data. Operational definition is time taken by associates to process a transaction. Number of samples are 256, and quality manager or operations manager will collect this data. Next, data collection should be done on shift. The measure type is X. Data type is discrete. Operational definition is transactions processed in which shift, morning or evening. Total number of samples are 256 and collected by is quality or operations manager. So this way you can capture data for all the X's which you have identified for your Y, and then you can go ahead and do data analysis. So friends, I hope data collection plan, sampling and different sampling techniques is clear to you. I have seen many black belts getting stuck in the measure phase and they are not sure what sample size they should take and what sampling technique they should use to take out the sample from the population, and how should they collect data. So when data collection is done, all the data points which are collected for Y should be collected for X's as well. That is the common mistake which generally black belts do. I hope this video will help you clarify your doubts. Do drop in your comments and share your views about the same. I will see you soon with another important topic in my next video. Thank you so much for watching. Friends, this is my first book which I have authored recently, 8 Steps to Problem Solving. So friends, this is a very handy book for all of you. I have covered almost all the topics of Lean Six Sigma here in a simple and concise way with easy examples.